Hello, this is Jeremy Hong from the Hong's Electronics Lab. Behind me and of course on screen is the HP 8753C, which is the VNA I ended up buying as my daily driver and will be using as so. Um, yeah, so it's a VNA that goes up to 6 gigahertz. The one on screen here is the 3 gigahertz variant with the 3 gigahertz S parameter test set. Um, so yeah, actually, as an important note, so whenever you buy these, basically the 6 gigahertz option is just a multiplier or a frequency doubler. So you actually have to, when it turns on this, it defaults to 3 gigahertz, and you have to turn it on to the 6 gigahertz mode or the frequency double mode to actually get that the extra 3 gigahertz that we all pay for, right? uh, so yeah, it's been quite fun using it in the lab here. Been just kind of doing some tests while I wait on my 4-layer FR408HR board from OSHPark with Ted Yapo's coplanar waveguide, and then um, basically a test circuit for one of the mini circuits low pass filters. Probably going to put a 4 gigahertz low pass filter to see how that performs, and on that waveguide, as well as just putting this VNA through its paces. Yeah, so here in this picture that you see in front of you, this is now the completed Hong's Electronics Lab. It has taken over, I think, let me think about this. This is about 4 years in the making now, because I think it all started with getting this Tenma power supply, at least in this current configuration, which was formerly from the MCM Electronics warehouse here in Dayton, specifically Springboro. When they were going out of business, or at least when that particular location was going out and being fully absorbed by Newark, they were selling these power supplies for about like $30, which is actually a great deal. And surprisingly, I keep learning from my coworkers and or clients and such that it's actually quite low noise, which is always pretty shocking to me, especially since I mean, I guess I'm always in the mindset that I paid $30 for it, so what do I expect? But yeah, it's normally, I think it's like $120 power supply, so I guess at that price it makes sense that it's fairly low noise. I haven't specifically characterized it, but in some tests conducted at work, they've noticed, or at least in one of my client sites, they've noticed that the noise floor is noticeably lower than on some of the other power supplies used. Um, but yeah, I brought it back because, again, I wanted to make sure this lab setup is complete. Uh, Otherwise, yeah, so I have my Rigol 1054Z or Z, as the EV blog likes to say. It's kind of fun. Very, very nice oscilloscope for the price, and of course hackable to 100 megahertz and enabling all the options as well. Then I have my 22 gigahertz HP spectrum analyzer, as well as a triple output Rigol, and then a Rigol multimeter, and then a Rigol waveform generator as well. So those are all, of course, behind me in the same place. And yeah, this is, I'm going to say this is the my small personal victory here at Hong's Electronics of establishing a complete lab for once. The VNA was finally the last item, at least in this phase, whatever phase this is, I don't know. I mean, at this point, I think I have enough equipment to really do some serious work. Because particularly I want to focus on L and S band, maybe some C band stuff with whatever common telecom and IoT protocols that rely on those frequencies, and even SATCOM. But yeah, I mean, I guess stretch goals for myself, maybe get some niche kind of test equipment. Maybe I need a RF waveform generator or RF signal generator. Not certain. I did buy one for the 8510 that I'm refurbing, but if I plan on turning that around, I plan on probably selling it with that waveform generator or that SIGGEN, because excuse me, synthesizer, because it's like a quarter of the VNA for it to properly work, and so yeah, might be still on the lookout for one. Fortunately, those are a lot easier to find than a VNA. So again, VNA is probably, um, I want to say, one of my bigger accomplishments as far as finding test equipment. Because wow, it's as I kept learning, it's not as abundant as a spectrum analyzer. I mean, I think the prices reflect that, because again, you can get the this spec and the 22 gigahertz one for, I guess, as low as 900 if you look in the right places on eBay. But don't know what exact condition that's in. But yeah, again, it's highly dependent on who sells it, where it's from, and other things. So yeah. But yeah, all in all, I think personally, since again, I like to say that I'm more of a hobbyist now, because I mean, behind me, and of course I do this as my career. So uh, to me, it's more or less just kind of like, oh, this is kind of like just the tax that I need to pay, right, to play at home and at work. So and just consulting. So yeah, so it's been a fun journey getting to this point, and yeah, can't wait to get in a steady stream of boards from OSHPark to test out, play around maybe with some flex boards as well, on that thinner substrate, uh, and yeah, maybe even sell some just for fun. Obviously, most of them will probably be open source. I mean, it's gonna be maybe just like one passive or two, and maybe an amplifier. Nothing too exotic. But the key being that everything will be tested, characterized. I don't know. I hope that when I sell a product, for example, on Tindy, it'll come with like a unique serial number, and then it'll come with a plot, or at least the customer will receive a email with the PDF of the plots, and then the S parameters also maybe in a zip file, just so that they have it. Because I guess kind of my target is not only just hobbyists, but probably targeting some of the lower end, or at least not lower end, I shouldn't say that. Probably some of the more price conscious minded military and aerospace companies that don't want to pay an exorbitant amount for a custom filter, but it just kind of like in that in between, because of course some of my clients are kind of like that, in that position where they're not like a Northrop or a Raytheon where they can just build these, and or like, I mean, to them it's just, you just write that off like no problem, no one bats an eye. But some places, I mean, all they ever use are mini circuits, parts, or components, and then whatever you can find on the distributors. So kind of targeting that niche, and of course hopefully even some of the bigger name customers will follow, because I mean, low prices, right? Yeah, so another thing I probably plan on doing is maybe playing around with different um, RF cans or cages for these filters and stuff. So actually putting a cover on them so that they're isolated from the environment, the noisy environment, because again, coplanar waveguide or just traces can become antennas if you're not careful. So pretty important. Yeah, so yeah. Oh yeah, I guess another thing I should shout out is, so I've had these for a while. I've been meaning to I mean, it's no secret at this point, right? These are Backplane prototyping systems from Clearwater Solutions, or Clearwater Concepts, I mean, not solutions, concepts. Um, it's just a nice prototyping system that I kind of invested in, that I think is pretty nice. It just, I mean, it looks nice for sure. I actually have one right here. The one in the picture here is with the Dr. Arduino Shield. with a breadboard. So yeah, like, this is entirely a circuit board underneath. It's a backplane basically, it's ground plane, what have you, and yeah, it makes a very nice, robust, and clean looking prototype. And the idea is, if you want to go on a field test and not have exactly a breadboard, but if you want to bring a breadboard, you can put it on at least a rigid base here. And wow, I just hit my microphone. That's okay. Anyway, yeah. So just a shout out. It's an independent guy out in Utah, and yeah, it's pretty. I like it. It's not a horribly expensive, especially for the presentation. I think it's well worth it. And yeah, and then I just have some random dual Vivaldi antenna that I played around with here from Tindy. I guess I might link that in this video as well. Yeah, it was kind of fun playing around with hooking that up to the VNA and then putting your hand in between. You could kind of see the S12 parameters just kind of change, or just the S12 through test kind of change, because you're changing the impedance of the air, or at least you're adding to this cap in line. So kind of cool in the near field, mind you. So I think that's it for now. I'm gonna try to post an update soon, or actually once I get the test board in, and then of course I mean, Ted Yapo's waveguide's gonna work, but just kind of looking at the mini circuits filter, 4 gigahertz. I originally tried to make it for 5. I mean, they're all the same package, but I realized that the stop band is actually beyond the range of this VNA, so that kind of defeats the purpose. So yeah, because I wanted to see a clear low pass and then a cut off, and then see the stop band on the plot. So yeah, just to put this VNA through its paces finally. And yeah, another thing that I've been playing around with in the meantime, I could have done this with a NanoVNA, but the problem, of course, with the NanoVNA is that the dynamic range isn't that great. Because again, when I was measuring some of the filters on the devices on the test board, this guy here that you can get for like 15 to 20 bucks off of eBay, like it clearly shows that, okay, like some of the narrow band devices here, or narrow filters, like the band stop filter at 6.5 and then a band pass filter at 10.7, it shows they exist, but they're not as clear. And then even in the PC software, you kind of see them, but I don't know, the plots just don't look right to me as well, or at least they're not as great resolution. I guess it might have been just, I might have just used the wrong amount of data points, which is always valid, but then you have to recal, I mean technically, because otherwise that's to interpolate based on the calcit again, or based on the data points. So yeah, at least on the 8753C, I mean, it shows very sharp band pass and band stop on those two devices, and then the Smith chart's very clear cut on some of these inductive and caps on here, or inductors and caps. So yeah, I'm fairly impressed with the A753C. I mean, I had never had a doubt in my mind that it would not be great. There's a reason why these things still cost real money. I mean, let me tell you, like a hobbyist like myself about 5 or 7 years ago would have never imagined buying one at this point. But I don't know. I think I've learned in all of this that, okay, if you decide this is what you want to do as a career, it is the tax that you pay as a hobbyist also to invest in this kind of equipment. Maybe that's just the answer that's clearly the answer with me buying and, finally succumbing to, might as well just buy it now. I have the money because of this job and my just consulting. Yep, it is, I think, in my opinion now, or at least me as an example, it is the cost of business, is what my conclusion is on that. Uh, yeah, so finally, actually, update on my NanoVNA. I think it's the Rev 2, is it? I think, yeah, the one that goes up to 3 GHz. It's finally cleared customs because I finally got an update from United States Postal Service after the actual I think the China Post tracking finally said it expired on their website. So I mean, it still shows a track, but the status is expired. But finally, glad to see that coming. Might do a comparison between all three of these behind me. Like, I mean, just for giggles and completeness. Yeah. So want to thank everyone to. I just want to thank everyone that's gotten me to this point in my career, and yeah, it's without all the YouTube guys that I've ever watched, like EV Blog, Dave Jones, and then Jerry Ellsworth, as well as Afro Tech Mods, and of course, more recently in the recent years is Signal Path Blog, of course, as far as RF stuff. And of course, to all my fellow ham radio operators, and also the Thursday night group, and then who actually we have a former Keysight / Agilent field applications engineer, so at least he kind of gave me the idea of buying one of these, because we have I think it's the 8753D, but that one has there's like, I guess, one with the discrete test set that is not as common, because the whole point of the 8753D was that the test set was integrated. Yeah, so yeah, thank you to everyone who's gotten me to this point. It's quite humbling. It really is. It's every time I look back, when the imposter syndrome hits, I'm like, how did I get here? Did I really deserve this? And just thinking back, kind of my blessings. Yeah, I guess everything did kind of work out. Yeah, it's yeah, it's been an awesome journey, and many fun years to come at this point. So what else do I have to mention here? And again, none of my videos are scripted, at least so far. This is just all off script, me just talking, ranting. Might be just mumbling and bumbling like an idiot. Like, sometimes, okay, for once, I'm not an orator by any means, so, but I try to get my stuff out there, because I know that lots of people just kind of enjoy listening to people that are just like, look, I'm just another person. I'm just another engineer. Nothing special. I make lots of mistakes. Like, I picked the 5 GHz mini circuits low pass filter instead of the 4 GHz like I should have, because I got overexcited and I ordered that. Oh, and I have to order that off of Mauser now. I just realized I didn't order it yet. We're all human. Yeah. So oh yeah, another note: you can buy mini circuits components off of Mauser. That was finally announced about 3 months ago, or actually before COVID, a little bit before COVID, which I'm glad, because the problem with mini circuits, I first experienced this when I was building the oh wow, I can't speak, wave bubble jammer from Lady Ada, which is a fully open source jammer. It's a swept noise, or swept CW 555 timer, creates the triangle wave that sweeps into the VCO, and then the sine wave sweeps, and that's a swept CW jammer. Yeah, because I had to actually contact, I think, Mini Circuits at that time for samples of those parts, or at least I had to quote specifically to, and they just kind of were like, oh yeah, well, fine, we'll do it. They aren't usually interested in doing that, but I guess again they got really tired of it to the point that, I mean, I don't know why they haven't done this in a while, but I mean, it's the demand for their components is pretty high. But yeah, now you can buy individual components at a premium, obviously, because they expect you to buy a minimum of reels of 20 of their components. So yeah, it's a very important note for any RF hobbyists out there. You can buy mini circuits, filters, cables, amplifiers off of Mouser now at individual quantities. And if you need to order reels, then just order off of mini circuits like you usually do. Yep, just please don't annoy them anymore, because apparently they just never liked that. But again, thank you, mini circuits. Without you guys, I would not be here today either. So thanks for putting up with hobbyists, ham radio operators, and engineers like myself who just want 2 of your components. Thank you. Okay. Yeah, so yeah, sorry, I think I already talked about, yeah, okay. So we're good there. Yeah, so I don't know what's next for me as far as the lab goes. Maybe, I don't know, but I saw that Keithley makes a $1,200 multimeter that has 100 femtofarad resolution on the capacitance range, and it's only $1,200, and it's a very capable multimeter. Recently got one at the client site, and I'm thinking about, but although this right, I really don't need that at all. Actually, the resolution's a little too much for me. This ragdoll's fine, as I tell myself as I cry to sleep. No. Anyway, yeah, so pretty happy with this VNA so far. I think what I want to do, because again, NanoVNA, it's great for the price, and it's best of all, it's mobile, it's portable. You can put in your, you can put in your pocket. Can't beat that. I mean, try to lug this thing. Forget carrying an 8510 around. Oh god, that thing is, what, the test set itself was like 45 pounds. Oh man, I can't imagine lugging that thing around. I guess it was meant to be in a rack to begin with, so. Yeah, so I'm probably gonna just do a 3-on-1, no, 2-on-1 comparison, or just 3-way comparison on the NanoVNAs. Or actually, no, I actually have 2 NanoVNAs of the last generation, so I guess I'll do comprehensive overview of all of them based on price, and then yeah, that's probably what I'm gonna do now. Yeah, so I think that's it for today. So thanks for watching my banter, and again, I don't have a script, so thanks.